Hi, I'm Hadi. I'm one of the team captains for Team 364 and want to give a brief overview of field-oriented driving, or FOD. FOD is not a complicated topic, but visual aid will help in your understanding. This is critical for both the software and the drive team, and I'm going to talk about the impacts of FOD for both camps. Now, if you're a member of the software team, I'd recommend you to watch this entire video, and if you're on drive, you can skip to the timestamps I've probably included, but it won't hurt to watch the whole thing. So first up, this grid represents the field and FRC competition, minus most of the bells and whistles of game elements. The stripped down grid will help us understand what's really going on. This blue square down here represents the robot, and the yellow lines I'm going to draw are going to represent potential paths for the robot to travel. The front of the robot is denoted by this little red mark at the top, and we're going to be talking about three major topics here. A non-FOD drive, then an FOD drive, and then a comparison between the two and advantages of an FOD drive. So without any further ado, here we go. So here's an example. Say you're in a car and you decide to turn left. Just let me build a path, and let's say we decide to go left. Okay, so now we've turned left. And let me draw a little version of the robot. So bear with me for a second. Okay, so let's say we had this robot here. So when I now press forward on the accelerator, let's use car terminology. When I now press forward with the accelerator, when you go straight, it's in relation to the car. Makes sense. So when I'm now pressing straight with the car, I'm not going to be going the direction you would think I'd normally be going based off of this grid. You'd actually be going the direction of the red part of the robot, which should make sense if you've ever been in a car. Now, this works perfectly fine for a car, because the key difference between a robot and driving is that when you're sitting back controlling the robot, you're in a third-person perspective. When you're in a car, you're in a first-person perspective. Because I'm going to now display to you the difference between the perspectives. So this grid right here more or less represents the driver's POV. This is how the driver sees the field. You have a grid like this where you have a positive y-axis and an x-axis which goes left and right, simple enough, basic graph. However, for the robot, it is now able to rotate this graph however it like. The graph will rotate depending on how much the robot actually decides to rotate. Here, the robot rotates 90 degrees, so the transformed graph is the exact same thing because, that's how our graph ends up. But let's take an example where you can actually see this impact, where it's not just a simple 90-degree turn like this. So to make my life a bit simpler, I'm just going to draw a little vector pointing to represent a turn. It's relatively the same exact thing, but it just makes my job a little bit easier. So let's make a vector here. Like that. And now let's say, let me set this angle to, let's say, roughly 43 degrees. This guy, oh, sorry. Let's say 43 degrees roughly. And this is the new position for the robot. Now the way the robot sees the field is not like this. The way the robot now sees the field is going to be very different. Let's take this new graph here, and I'm going to transform this. So I have this selected, and let me go here, and boom. So now I'm going to rotate this in accordance to the field. Don't get scared by the sanity of what this looks like overlaid, because honestly it's not as bad as you think. So let me show you the two graphs. So remember, this one over here, this white one, is what we, the drivers, see when we look at the robot. Now, this is what the robot sees. Because, let's remember, when I go forward with the robot, when I press forward on the accelerator, it goes this way. And oh, look what happens here. This XY plane now has a positive Y along this way, and its x-axis goes along this way. And this should all make sense now. Because now when I press forward with the accelerator, you go this way. You don't go up like that. Let's go reset back to a standard field, because I think that illustrates the point well enough. Okay, so that is more or less a simple FOD drive. Now, that can seem a little bit confusing what I just did there, and that's definitely one of the issues. This here is one of the real big problems of an FOD drive. Now let's say I have an obstruction. Say in Rapid React's game there is a big goalpost in the center. Let's say I'm sitting back here with the robot, and now the robot's back here. And now let's, for sake of comparison, let's say there's a few other robots surrounding it, so it's a bit blocked. Let's just say the center one is our robot. So, okay. So now we have the center robot over here. So now when we look at this robot, we have the big issue. A, we have a big goal obstructing it, and B, we have a bunch of robots next to it, which are also obstructing our vision. Typically we have a limelight installed, which can help us actually understand the way the robot's working. However, in this case, we don't have that luxury really because there's other robots obstructing our vision with the limelight. So in this case, we're effectively completely blind as a driver because no one can really get a view. And this is incredibly stressful. Because now when I'm hitting on the joystick trying to get myself out of there, I don't know which way I'm actually end up going. So if I try hitting forward, I can go this way. Say the robot's turned a different way, I don't know. It could be going that way, that way, that we really don't know. And this is where FOD really can play a big impact. So now let me introduce FOD. So what FOD does, it sees this grid, let me remove this obstruction. It sees this grid over here as immutable, which is to say it does not change no matter what. What the driver sees as this grid is what the robot sees, and they will never diverge. These two graphs, the white one and the gray one, are always coincident and they will never change no matter what. I'm emphasizing this because this is what that actually means in practice. Let's say I go make the same exact turn I did before. Now obviously the robot is going to be rotated because, you just made a turn, but here's the important thing to note. Now when I have this robot, actually, let me, I'll just go change the direction. Starting here, and now I have, sorry, it's just being a bit weird. Alright, so now I have the robot like this. So obviously the robot is no longer facing the same way. So as you'd expect from standard non-FRD driving, when we press forward on the accelerator, it's going to go to the right. However, this is not how FOD works. Now, I'm going to denote what the robot thinks is its front in a darker red. So let me just quickly put this in. This dark red bit here is what the robot actually thinks is its front. What the robot thinks now is that this little part of it is what front actually is for it. Now, obviously this is coincident for the original example because they're, same case. Now, what this means in terms of its motion is that over here, when I hit forward on the accelerator, I'm not going to go this way. I'm actually going to go this way. And if I had the case where the robot was turned a bit more, let's say instead of being nicely like that, say it was turned more for some reason. Let's say, I'll make it non-standard angle. Let's say it's like that. When I press forward on the robot, as you can guess, it's not going to go this way, the way the red part is pointing. It's now actually still going to go the same way we had before, if I could actually get drawing there. There. So when I press forward, it's going to go this way. Not this way. This does not happen. It's this one which happens. Because once again, FOD always has forward as that direction. Hopefully that makes a bit more sense. And now let's bring back the example with the obstruction. This hopefully will now let you see the real power of this. Say we're being blocked in and we can't really see what's going on. Now, in a panic to try and get out of there, say I'm the driver, I want to get out of there no matter what. Say this robot actually, we make this even more, obscure so you actually understand what's going on here. Let's say the robot's pointed I don't know, that. And I want to move it out to the right so I can go out. Now what happens if I floor right with the accelerator, I'm actually going to go in a different direction than you think. I'm going to go, get yellow for the path. I'm going to go this way. I'm not going to go forward like that. I'm going to go this way because this is what the robot thinks right is. And this is highly useful because no matter what, if I press right on the controller, it's going to be in this side of the field. If I go left, it's always going to end up this side. If we go down, it's going to go this way, obviously, and up this way. Now, this is incredibly useful because that is a very common problem during the game. And for drivers, you should understand this is a very helpful mechanic because it can be a bit weird to do back at home, but when we're in the competition, this is a very much of a game changer. And here's where its power really comes to fruition. If we have the example of having a different type of drive base, instead of a standard tank drive mechanism, we now have a swerve drive or a mechanism drive. Typically we'll be using swerves from now on. A swerve drive mechanism will now enable us to have two drivers using two controllers, because you can have translational motion located in one and rotational motion located to the other. Now, the big change here is that if player 1 is using that first controller to move translationally, once again, field-oriented drive will let them move around the field however they like. And now when controller 2 is going to be turning the robot about, as we just demonstrated, it will make a difference to player 1 because they can go move around however they like. It's completely unaffected. You can go look at some swerve drive documentation or tutorials if you'd like to have a better understanding of how that works. Hopefully, this has shown you the benefits of FOD, and thank you for watching.